recall that the yield to maturity is the expected return for a bond, expected annual return for a bond. And we can find it if you know the present value of it, so it's the price or the market value, and you also know what the promised cash flows are. Those come from the coupon rate and the face value times to maturity, as well as the frequency of payments, whether it's annual or semi-annual. Then you can find the yield to maturity of a bond. And a financial calculator is a wonderful tool to do that, because what you're basically doing is you've got each coupon, which is equal to the coupon rate times par, which captures how much each bond pays in coupons over the course of a whole year, but then you divide by the number of coupons per year to get the actual coupon. So if a bond pays $150, has a coupon rate of 15%, 150 per year, it's either annual, one coupon of 150, or if it's semi-annual, it's two coupons of 75. Every 6 months is 75. Again, that's PMT is going to equal that. How many of them are there? There's N of them. N is just the number of years until maturity, but you have to multiply it by the number of coupon payments per year. So if it matures in 10 years, but it pays semi-annually, that's 20 half years. If it matures in 10 years and it's annual coupons, that's 10 single years. Par value is going to be FE, 1,000. We'll always have 1,000. Also, we'll always be in N mode because we always assume the next coupon's in one period. You tell the calculator what the bond value is. You put in the opposite of the bond value for PV. And then you go ahead and solve for I%. And I% is the discount rate for one of these periods. So in order to get the yield to maturity, which is annual, you need to multiply I%, which is R, times the number of coupon payments per year. So again, if you get a 6-month period, you got to double it to get it for a year. If one period's equal to a year, you've got the rate that you need. So let's look at a couple of examples. We have a bond with an 8% coupon rate, 12 years to maturity, par value of 1,000, price is $956.16. Annually, next one a year, what's the yield to maturity? Well, the first thing you need to do is find the discount rate such that the present value of the promised cash flows is equal to the price. And so again, 8% coupon annually is $80, 12 years, so you got 80 in 1, 80 in 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Dividing them all by 1 plus R to the power of how many years they're going to be, plus 1,000 at maturity, discounted by 12 periods. And so again, a very important thing is to understand why this equation holds. The present value of the 12 coupon payments of 80 plus the par value payment of 1,000 at maturity is equal to $956.16. Then we'll get R. We need to annualize it. In this case, it's paid annually, so R is an annual rate, so it is the yield to maturity, and so we're done. So let's let the calculator do the work. N mode, FV of 1,000, that's our par value. What is each payment? It's 8% times 1,000, which is 80. There's only one of them per year, so each payment's 1,000. How many of them are there? There's 12. 12 years, one per year. Bond currently priced at $956.16. What's the discount rate that equates those expected cash flows, those promised cash flows, with the price? 8.6%. That is a rate for a year. That's yield to maturity. So what we just found is that if we were to discount all of 13 payments, the 12 coupons and the par payment, by 8.6% per year, we get $956.16. Let's look at a case with semi-annuals. 8% coupon again, 12 years to maturity, par of 1,000. Now the price is $1030.78. We got semi-annual coupons with the next one in 6 months. So again, we want to find the discount rate such that the present value of all of these coupons plus par is equal to $1030.78. But then in this case, won't jump ahead. In this case, you need to annualize it. And since we're going to be getting a rate for 6 months, we're going to need to multiply it by 2. We'll have the 6-month rate, we want the 12-month rate, so we have to double it. So again, start with the easy ones. N mode FV of 1,000. What is each payment? Well, it's 8% of 1,000 is 80 per year, but there's 2 per year, one every 6 months. So every 6 months, this bond has a $40 coupon. How many of them are there? Well, 12 years to maturity, 2 coupons per year, so it's 24. And correspondingly, we get 1,000 in 24 half years. Price of the bond, so enter PV is the opposite of the price of the bond. Go ahead, solve, and the discount rate that will make the cash flows equal to 1030.78 is 3.8022%. Double it to get the yield to maturity, 7.604%. What we just discovered, just to reiterate, is here we have the 24 coupons, plus we have the par value in 24 half years or 12 years, and we found the discount rate such that if we discount all 25 of these and add them up, we get the price of the bond.